Alright, so congratulations on finishing the section on the level editor. It was a long section, there was a lot of information to get through, but you did it and you're here and now you know the ins and outs of the level editor and are fully prepared to move forward. So you've learned the basics of what an actor is, and you've learned how to place them in a level and rotate and scale them and so forth. Now in this section, you'll be learning about several different types of actors and how each type can enhance your levels in cool and unique ways. You're going to learn about an actor that can be used to prototype your levels, and about actors that can represent physical objects. You're going to learn about actors that can generate light, actors that can generate fog, and actors that can define a volume of space. And then at the end of the section, we will start working on our tutorial game. So there's a lot of fun stuff to look forward to in this section. And for this lecture, I'm going to be discussing the static mesh actor. So the first thing you need to know is what a mesh is. A mesh is simply a 3D model of an object. There are two specific types of meshes that you can use as actors in the Unreal Engine. These are the static mesh and the skeletal mesh. So a static mesh is a mesh that doesn't bend, deform, or change shape in any way. A static mesh can still move around on the screen, it just can't animate. So for example, you could use a static mesh in the shape of a cube to represent a cardboard box, and you could have that box slide across a surface or fall off a table or fly across the room, but you couldn't have flaps that open and close. For objects with moving parts, you would use a skeletal mesh. With the skeletal mesh, you can define individual parts of the mesh and how those parts connect and move with one another. So static meshes for objects without moving parts and skeletal meshes for objects with moving parts. Now that being said, we will mainly be focusing on static meshes for this beginner's course. So there are a few different static mesh actors in the Create menu. In the Shapes category, there are static meshes in the shape of a cube, sphere, cylinder, cone, and plane. So I could drag any one of these into my level and then position it and rotate it and scale it as I wish. So you have those static meshes in the Create menu, but more often than not, you will be dragging and dropping static meshes from the content browser that you import in. So the starter content comes with some static meshes, for example, this furniture here. And there are some architectural meshes as well. But this is a very small supply. So you will want to be importing in meshes that you download or create yourself in a 3D modeling application. And I'll show you later on in the course where you can download collections of meshes and other content for you to use in your games. Alright, so now that you have a basic understanding of what static meshes are, I'll discuss using them in the Unreal Editor. So again, like other actors, you drag static meshes into your level and position them and adjust other properties to your liking. But what if I position a mesh just where I want it and then decide I want to use a different mesh in its place? I could delete this actor, drag in a new mesh, and then do the work again to position it and rotate it and so on. But a better way would be to use the Details panel to replace the static mesh that the actor is using. So in Unreal, the static mesh itself is actually a property of the static mesh actor. So for example, if I position this chair just how I want it, and then decide I want there to be a couch here instead, I can select the chair, then go to the static mesh category of the Details panel to replace the mesh being used by that actor. So one way to do that is by using this drop-down menu here. So I can click on this and then find the couch mesh I want to use. And notice this menu contains a search box that you can use to search for the asset you want to use. So when I click on the couch, it will replace the chair with the couch, and the couch will have all the same properties the chair had, including position, rotation, and so on. Because technically we didn't replace the actor, we only replaced the mesh that the actor was using. Another way I could have selected the couch or any other static mesh I wanted to use would be to browse to it in the content browser, select it, and then click on this arrow here. So this arrow will replace this asset with whatever is selected in the content browser when you click it. Okay, the next thing I'm going to talk about is applying physics to your static meshes. By default, static meshes have physics turned off. So if I place a cube mesh in my level and then press play, you will see that the cube doesn't fall to the ground, it just sits there. Even if I press up against it, it won't move at all. It's like a Snorlax on Benadryl and ginseng, okay? It's not going anywhere. Unlike these other cubes, which react to the force of the projectile or the force of the character walking into them and pushing them. So there's two reasons why this cube mesh isn't behaving the same way. The first reason is that its mobility is set to static. When the mobility is static, we are telling the engine that this actor will never change its position or rotation for any reason. So the first thing we need to do is set the mobility to movable. By setting the mobility to movable, I would now be able to, for example, create a blueprint with some movement logic in it that tells the cube how to move around in the level, something you will learn how to do later in this course. But even with the mobility set to movable, this cube still won't react to force from other actors because it doesn't have physics enabled. So to do that, with the cube selected, I'm going to go to the physics category in the details panel and check the box next to simulate physics. So if I press play, you can see that the cube now falls to the ground. And if I push it, my force will move it along the ground. And if I fire a projectile at it, it will react to the force of the projectile. So as you can see, there are some other properties under the physics category. One of them is the mass of the actor, measured in kilograms. Objects with more mass require more force applied against them in order to be affected. So if I make this cube really massive, shooting it won't move it much. But if I make it a lot less massive, it will go a lot farther with the same amount of force applied. So the next two properties are linear damping and angular damping. Damping refers to the amount of drag that is applied to the movement of the object. So similar to having more mass, the more drag an actor has, the harder it is to move. But in this case, drag is meant to represent friction on the object. So if this cube were a smooth block of ice, it would have less drag on it than, say, a rough block of stone, even if the two had the same mass. The linear damping property affects translational movement of the object, meaning a change in location, while the angular damping property affects rotational movement of the object, meaning a change in rotation. So by increasing the linear damping, when I shoot this object, it won't go as far, although I can still make it spin fairly easily. But if I decrease the linear damping to a negative value, it will travel a far distance when I shoot it. But now let's say I turn the linear damping up and turn the angular damping down. When I shoot it, it won't go far, but it will rotate a lot. Okay, so below the angular damping property is the enable gravity setting. So if I turn this off, but leave simulate physics on, the cube will still react to force, but gravity will not affect it. So if I press play, the cube will start off stationary because without the force of gravity affecting it, there are essentially no forces affecting it right now. But if I push it, it will start to move. And unless it collides with something else to stop its momentum, it will continue moving. So this can replicate zero gravity environments like being in space. Below the enable gravity property are the constraint properties. These allow you to prevent translational or rotational movement in specified directions when the mesh is affected by physics. So one way to do this is to use the lock position and lock rotation properties to lock the movement of one or more of the three main axes. You can use the mode property to select from some presets or to define a custom plane that doesn't run directly parallel to one of the three main axes. For example, if I place this cube in the air, when I press play, it will fall to the ground. But if I lock the position of the mesh along the z-axis and then press play, it will be unable to change its z location even though there is a downward force being applied to it. And then the next two properties allow you to ignore radial impulses or forces that would otherwise affect the mesh. Radial means rotational. So for example, let's say you're simulating a game of pool. If you were to select the 8 ball and check ignore radial force, and then you simulated the game and put some backspin on the cue ball, when it collided with the 8 ball, the backspin wouldn't have any effect. Only the translational movement of the cue ball would affect the 8 ball. Alright, and then the next property determines if damage to the mesh should cause a physics impulse to be applied to it. The damage system will be covered later in the course. Alright, and then the final property here is replicate physics to autonomous proxy. This is used in multiplayer games and should be checked if the server is in charge of keeping everything in sync, and unchecked if the clients are responsible. And that will conclude the lecture on static meshes.